Good morning to everyone. Today we are going to see about the laboratory experiment. The subject code is 24EC202L Circuits and Devices Laboratory. Experiment number 7. Characteristics of PN junction diode and Zener diode. Let us see the circuit diagram. Listen, this is what our circuit diagram. We need one PN junction diode, 1 kilo ohm resistor, 1 voltmeter, 1 ammeter and 1 power supply. The supply range is 0 to 30 volt, 1 kilo ohm and diode having a 2 terminal, one is anode and cathode, voltmeter 0 to 3 volt, ammeter 0 to 20 milliampere. Let us see the circuit connection. This is a diode. It have a 2 terminal. One is an anode and another one is a cathode. It having a white color ring. This is a differentiation. We have to find out the anode and cathode. We have to do the connection. It is an 1 kilo ohm resistor. Brown, black, red color coding. This is a 1 kilo ohm resistor color coding. We know that. We have to connect the one end to the anode terminal and another end we can keep in another end. And we are giving to the power supply to the one terminal of the resistor, and the negative of the supply need to connect to the ground. Next, this is an voltmeter. It have a 2 end, positive and negative. The range of voltmeter is 0 to 3. The positive terminal of the voltmeter is going to be connected to the anode. This is an anode terminal, one end. We have to connect the positive of the voltmeter. Negative need to connect the cathode terminal. Next, this is an ammeter. It is a milliammeter. We are having the range is 0 to 20 milliampere. The positive terminal of the ammeter is going to be connected to the cathode. This is a cathode terminal. And negative is going to be connected to the ground. Next, we can switch on the supply. We are having 0. The switch on the supply, we are having 0.0 in the RPS. Next, we want to increase the fine voltage S1, 1 volt. We are having the voltmeter reading 1 volt. Note down the reading. Applied voltage is 0.1 and the forward voltage is 0.1. We note down the current value as 0. Here the voltmeter value is 0.1. The current reading is 0. Next, we have to note down the second reading. We increase the 0.2, 0.3. We can applied voltage is 0.3. Our voltmeter reading is 0.3. The voltmeter reading is 0.3. Next, the same time we are measuring the ammeter reading. It should be 0. We note down the 0 value. The next reading, we want to increase the voltage supply voltage as 0.7. Here forward voltage is 0.4. Here there is no milliampere reading, it's a 0 value. Next, note down the next reading. Our supply voltage is 3.2, our forward voltage is 0.6. We are having a smaller current, it is a milliampere current, 0.12, 2 milliampere. It is the smallest current. Next, we have to increase the supply voltage. (17.7) is regulated power supply voltage, and our forward voltage is 0.7. Our millimeter range is 16 milliampere. We know down the 16 milliampere. Next, again we have to take the one more reading. While we are increasing the supply voltage, 19.0, we measuring the voltmeter reading as same as it is 0.7. We are having the increased current 18 milliampere. Next, we have to take one more reading. The power supply voltage is 23. Next reading, our supply voltage is 21. We measuring the voltmeter reading the same as it is 0.7. We are having the millimeter reading is 19.5 milliampere. From this analysis, while the diode reaching the cut-in voltage means where the diode starts conducting, it is nothing but cut-in voltage. Beyond the cut-in voltage, we are measuring the current reading as increased value, and we are having the forward voltage as it is same. This is nothing but our forward voltage and forward current. This is we have to measure in terms of graph. After reaching the 0.6, we are having a smaller, the current is going to be increases. While reaching the 0.7, the current is going to be increase without changes of the forward voltage. From the PN junction diode, we have to understand about the voltage increases. It means that after certain cut-in voltage, the voltage not increased, but the current is increases. This is the one of the application where we are going to use the PN junction diodes as a regulator, as stabilizer. In this application, we are maintaining the same voltage, but the current is increases. Thank you. Let us see PN junction reverse bias circuit. This is a reverse bias circuit. We are going to do the connection. We have to do the connection. It is an diode. We have to insert in terms of reverse connection. It is an cathode, it is an anode. Here the ring is here. Here the ring is here. So we have to connect like that. Next, we have to take 1 kilo ohm resistor. The coding is black. brown, red. We have to connect one end to the cathode and one more end. The first terminal is here. Next, RPS positive is connect to the first terminal of the resistor. First terminal of the resistor, and negative is going to be connect in the ground. Next, we have to connect the voltmeter across the diode. Positive is connected to the cathode terminal. This is our cathode terminal. We have to connect here. Negative going to be connected to the anode terminal. It is an anode terminal of the diode. We have to connect it here. Next, for the reverse bias, the small current will be flow. So we have to take a microammeter, the range of 0 to 250 microampere. The positive terminal of the microammeter going to be connect in the anode terminal. Negative is going to be connect as ground. Once the connection is over, we have to switch on the supply. We are getting 0.0 voltage initially. And next, we have to increase the voltage 0.1. There is no voltage. There is no flow of current. And next, I am increasing the fine increasing of the voltage is 1 volt. The applied voltage is 1 volt, and reverse bias voltage is also 1 volt. The current is 20 microampere. We note down the reading. Applied voltage is 1 volt and reverse voltage is also 1 volt, and the reverse current is 20 microampere. And next we have to adjust the supply voltage. Increase the supply voltage as 2. This voltage, reverse voltage is also 2. We are having the current is 50 microampere. Next, we have to adjust the supply voltage. As 3 volt. Here the applied voltage is 4. Here the reverse bias voltage is 3 volt. The current reading is 95 microampere. Next we have to increase the supply voltage. Here is an 5.8. The reverse voltage is 5. The reverse current is 110, 120, 130 microampere. 5 volt. It is current, reverse current is 130 microampere. Next, further we have to increase the supply voltage as here the applied voltage is 9. We are getting a reverse voltage is 6. Reverse voltage is 8. We are measuring the current is 200 microampere. Next we take on one more reading. Our applied voltage is 10 point and the reverse voltage is 10 volt and our current is 245 microampere. Here the voltage increases, reverse voltage increases, the reverse current is also, minute reverse current is also increases. Let us see the experiment Zener diode. This is Zener diode. It have a two terminal. One is an orange in color, another one black in color. Orange color is anode, that black color is an cathode. We have to connect the Zener diode in the breadboard. Next we have to take 1 kilo ohm resistor. That 1 kilo ohm resistor is going to be connect one end of the anode. Next we have to connect the RPS supply to one end of the resistor. The ground is going to be connected in the ground line. Next we have to take a voltmeter. The range is 0 to 3 volt. The positive terminal of the voltmeter is going to be connected the anode terminal. This is an anode terminal. We have to connect this line, anode line, and the negative terminal is connected to the cathode of our Zener diode. Next we have to take an ammeter. The range of ammeter is 0 to 20 volt, 20 milliampere, 0 to 20 milliampere, and the positive is connected to cathode line and negative is connected to ground. Next we can switch off on the supply. We have to increase the supply voltage as 0.1. We have the apply voltage is 0.2. The forward voltage is 0.1. Our forward current is, there is no flow of current, so we have to write 0 as forward current. Next we can increase the RPS voltage as 0.3. The forward voltage is 0.2. The forward current is 0. There is no flow of current. Next I am increasing the supply voltage as 0.4. There is no flow of current. The forward current is 0. While we have to increase the supply voltage as 0.6, the current is minute milliampere current we measured here. It isn't 0 to 5. Here we are getting 0.5 milliampere. Next I am increasing the supply voltage as 0.7. Our forward current is 3 milliampere. Next, I am increasing the supply voltage. I am increasing the supply voltage as 7. Our forward voltage is 0.7. Our forward current is 6 milliampere. I am writing 6 milliampere. While increasing the next level of the RPS as 10 volt, our voltmeter reading is same as it is 0.7. We have the millimeter reading is 6, 7, 8, 8.5 milliampere. Similarly, we have to take the another reading. The supply voltage is 15. Our forward voltage is 0.7. We are getting the Zener diode forward current is 11, 12, 13, 13.5. 13.5 milliampere. Like this we have to take the reading. From the reading we have to analyze the voltage. Forward voltage increases, the starting point of voltage increases up to 0.7. There is no forward current. Here the 0.6 the current is going to be start, it is 0.5 milliampere. After 0.7, after reaching the cut in voltage, the current only we are getting the increased level. This is, in this way we have to take down the reading and draw the graph like this. Here it is in 0 point, there is no flow of current. While reaching the 0.6, we are getting 0.5 milliampere. Certain period, it is an 0.7 cut in voltage, we are getting the increased current. Thank you. Let us see the Zener diode reverse bias connection. Here this is our circuit diagram of reverse bias. Here Zener diode we have to take. Here cathode is here and anode is here. We want to just reverse the anode and cathode. Here the cathode terminal is in black color. This orange color is anode terminal. Just we reverse the diode and the other similar connections are same. Switch on the supply. We have to increase the RPS voltage as 0.1. Applied voltage is 0.1. Our reverse voltage is 0.1 and our reverse minute current is 10, 20, 25 microampere. 25 microampere. And next I am increasing the supply voltage. Here the applied voltage is 0.4. Our reverse voltage is 0.2. We are having the current is 60, 70, 75 microampere. We can write 75 microampere. Again we are increasing the supply voltage as 0.3. Our reverse voltage is 0.3. Reverse current is 115 microampere. Next I am increasing the supply voltage as 0.8. It is our applied voltage. we are getting the reverse voltage is 0.4. Our reverse current is 150 microampere. Next I am increasing the supply voltage 1.0. It is our applied voltage. Our reverse voltage is 0.5. Our reverse current is 160, 170, 180 microampere. Next I am increasing the applied voltage is 1.2. We measuring the voltage, reverse voltage value as 0.6. Reverse current is 210 to 20 microampere. Similar way we have to take the reading graph. Let us see how to draw the graph. This is in reverse voltage, this is in reverse current. So we have to draw the graph in fourth quadrant, first to third quadrant. Let us see how to draw the graph. We want to draw the graph versus reverse voltage versus reverse current. It is our third quadrant. We want to draw the graph for VR versus IR here. The 0.1 voltage we are having 25 microampere. So the point we have to measure it. Note down the point here. And next the reverse voltage is 0.2. We are having the reading is 25 microampere, 75 microampere. So we have to point the line here. Next our reverse voltage is 0.3. Our reading is 115 microampere. Approximately it is in 115. It is in 115. We are having the line point is here. Next our reading is 0.4. The value is 150 microampere. This is what our 150 microampere. This is the point. We are having the reading 0.1 to draw the line like this. This is what our reverse bias graph. We can understand from the PN junction diode graph and reverse bias graph. In the PN junction we are getting only the forward current. There is no reverse current in the reverse bias. But in the Zener diode we are having the forward current and also the reverse current. This is the one of the advantages of Zener diode. Thank you.